Here. So product and quotient rule. This is day 5 of unit 2. Originally recorded the 25th of August. Product and quotient rule. Okay, in previous sections we did sum and differences, and there's not really a rule because it just sort of works like you think it would work. The derivative of f plus g is the derivative of f plus the derivative of g. Like we've already done this, maybe not 100 times, but a whole bunch of times, and we didn't really even think about it. 21x to the 6th, 36x squared minus 17. We just took the individual pieces and added or subtracted them together. So sum and difference. So there's not really a sum and difference rule. It just works like you think it would work. The trouble is, the product doesn't work that way. You can't take the derivative of f and the derivative of g and just multiply them back together. So it's more complicated than that. But this is going to be the trick that people fall into. It's just, I'll just multiply the two together. So if we wanted the derivative of 5x sine of x, it is not, let's see, the derivative of 5x is 5, and the derivative of sine is cosine. I'm hesitant to even write that down because that's not close to right. So for multiplication and division, you can't do the kind of what you think you ought to be able to do. The things you're able to do with adding and subtracting, you can't do that with multiplying. So here's our product rule. The derivative of f times g. So there's a lot of letters in here, but basically ignore the x's the first time through here. F prime times g plus g prime times f. Now, it's adding, so the order doesn't matter. That's what makes the product rule easier than the quotient rule. Is that the order doesn't matter? That makes sense, right? Because in multiplying, order doesn't matter, but in division, order does. And so it's the same for the derivative of them. And because the order doesn't matter, it doesn't really matter how you memorize it. It's one derivative times one original plus the other way around. So I don't always do f prime times g. Sometimes I do g prime times f, but it doesn't matter. So derivative of one times the other plus the other way around. Like that's the concept way to think about the product rule. Super important. I guess the good news is you're going to use it so often that you'll have it memorized soon enough because we use it all the time. Example 1. F of x equals, okay, this thing times this thing. And you can't just take the derivative of one and the derivative of the other and multiply them together. I'm going to sort of slow it down on this first one and say that first piece is f and the second piece is g. This might get a little confusing because the overall function is f, but I just want to label f and g so that I have f prime and g prime. And so f prime and g prime, like separately on their own, are pretty easy enough that I could call on Tyler and Brandon to tell me those things. So Tyler, what's f prime? Just the derivative of that first piece.
Just 4x to the third minus 6x plus 9.
Good. And Brandon, how about the derivative of the second piece?
10x to the power 4 plus 4x to the power 3.
Yes. So now I'm ready to put them together. I'll make it match the formula exactly, f prime times g. So that's those two put together. So f prime is 4x cubed minus 6x plus 9 times g 2x to the 5th plus x to the 4th minus 12, plus, the other way around, g prime times f, 10x to the 4th plus 4x cubed times f is x to the 4th minus 3x squared plus 9x. Put that where you can see it. So all of that is the derivative. So it's like way more complicated than just derivative of f, derivative of the first piece times derivative of the second piece. It's one of the pieces times the derivative of the other plus the other way around. Now, I showed a lot of work on that. I showed f, I labeled g, I found the f prime and g prime, and then I put it together. Once we get rolling on these, a lot of you are not going to show that step. Some people kind of go in the middle, and to help them keep track, they'll label f and g, but they'll just sort of write f prime when they need it, and write g prime when they need it, rather than having to write it twice. So I'll probably switch to skipping some steps here in a minute. Number 2, find the instantaneous rate of change. Again, that just means derivative of x cubed sine x with respect to x in terms of x. Find the derivative. So I'll kind of go halfway on this one. I'll call x cubed f, and g I'll call sine x. So f prime g. So f prime is 3x squared. G is sine of x. And then plus g prime f. Derivative of sine is cosine. Derivative of f is, or no, not the derivative of f, just the original f, x cubed. It looks weird to put x cubed at the end of a cosine, so I'm going to squeeze it in here at the beginning because that's how it would probably look. So, kind of split the difference on show and work on that one. I labeled f and g, but I did not explicitly state f prime and g prime. I just used them when I needed them because they were simple enough. If you get something crazy, then maybe it's worth it to take the time to figure out f prime and g prime. Number 3, find the slope of the line tangent to the curve. So g prime. When x equals pi over 3. So at pi over 3. So kind of the same deal. I'll just take my derivative, but then I'll plug in pi over 3 at the end. This one's a little bit different because of that 6. It's like, what do you want to do with the 6? We've got options. Now let me ask it this way. What function do you want to call f? Good. That's probably the best way to do it. Just put the 6 on the sign, and then you don't have to worry about the 6 anymore. The other way to do it is to hold the 6 out front of everybody, do the product rule, and then stick the 6 back on. But I think it's easier to just assign it to one of them, and then do f prime g plus g prime f. So f prime g, derivative of f would be 6 cosine x. G is tangent of x. F prime g plus g prime f. Derivative of g is secant squared. F I don't need to do anything with. 6 at the end is going to look funny, but oh well, I'll do it. Times 6 sine of x. So I'd probably move that 6 to the front to clean that up a little bit. Okay, now for unit circle. 6 cosine pi over 3, tangent pi over 3, secant squared pi over 3. I'm going to move the 6 out front. Sine pi over 3. Getting short on space here. That's a safe stop, right? Because it's calculator ready. There's no calculus left. So free response question, you could leave it like that, but we're not going to have free response questions that look like that. Cosine pi over 3 is 1/2. Tangent pi over 3 is root 3. Again, hopefully you know these quick enough to do these, because they're just, there's 4 of them in there, and if it takes you 2 minutes to figure out each one of those, well, then this is like turned into a 10-minute problem. Secant squared. Secant squared is the flip of cosine. Cosine is 1/2, so 2 squared. And then sine is root 3 over 2. Again, safe stop, but we've come so far. 3 root 3 plus, 6 times 4 is 24 divided by 2 is 12. So 15 root 3 would be our multiple choice answer. Safe stop answer was way back here. All right, number 4 is the last example, so why don't you try number 4? And then at 2, so make sure you plug in 2. Let's see, 4 times 2 is 8, minus 16 plus 1, plus, oh, well, that's nice. 4 times 2 is 8, 8 minus 8 is 0, and then it doesn't matter what the rest of that part is, because that would be wiped out. 3 times negative 8 plus 1 is negative 7, negative 21. Questions on product rule? Again, most people get the product rule just fine because the order doesn't matter. So as long as you got one of them times the derivative of the other plus the other way around, you're fine. Again, people generally don't mess up the product rule. As opposed to, turn the page, the quotient rule. Quotient rule is a little more complicated. As expected, right? Division is always a little more complicated. F prime g minus g prime f all over g squared. I'm going to write that a little bit differently. I'm going to drop all the x's out of there just because it's a little easier to look at. I'm also going to switch the order of the multiplication because it helps me with my little memory device. Gf prime minus fg prime over g squared. Gf prime minus fg prime over g squared. A couple of things to note. No derivative in the bottom. So that's kind of weird, maybe. Why in the world is that g squared there? And then this is how I remember the quotient, or the quotient rule. And the quotient rule is sort of like high school relationships. You're like, oh no, bad joke approaching quickly. If you want your high school relationships to work, and here's the other thing about the quotient rule: the girls like have an intuitive feel for the quotient rule more so than the guys, because if you want your high school relationship to work, and if you want the quotient rule to work, the GF has to come first, right? Groan, smile, whatever. But that helps me remember which one is first, because it matters in the quotient rule. It matters in division. You got to get the signs right. So product rule, when you're multiplying, who cares? It's just 1 times the derivative of the other plus the other way around. Easy. Quotient rule, you got to remember which one's positive. And so my way to remember that is gf prime minus fg prime over g squared. The girlfriend has to come first. I've heard other calculus teachers phrase it this way. Low D high minus high D low over low squared. What that means is that the f is the high function and g is the low function. So it's the low one times the derivative of the high one minus the high one times the derivative of the low one over low squared. I don't know. I never found that particularly helpful. But if that's kind of a sing-song thing that you can latch onto, then go for it. Low D high minus high D low over low squared. Girlfriend has to come first. Or just good old GF prime minus FG prime over G squared. But you can see how it's more complicated than the product rule because of the subtraction. Now for this one I usually do take the time to write out who F and G are. Like I did that on the first one with the product rule. I do it more often with quotient rule because there's just more to keep up with. So in this first example, F's the top one, G's the bottom one. So I'm going to take the time to write out F prime and G prime, and then I'll put it all together. I just feel like trying to handle the equation and the derivatives all at once in my head is too much. So I'm going to find the derivative of the pieces, and then I'll have everything I need to do the quotient rule. So, Will, how about the derivative of the top? Just the derivative of the top. Just 5. Like sometimes you catch an easy one. Rabia, how about the derivative of the bottom? 2x. Okay, so those are easy, but I like taking the time to write them down because now it's just a matter of putting the pieces together here. So the GF has to come first. So that would be, well, x squared plus 1 times 5, but I feel like that would work better if the 5 was out front. 5 times x squared plus 1. Minus the other way around, or minus the other pair. 2x times 5x minus 2. All over. Now don't mess with the bottom. Don't take the derivative of the denominator. Just square it. So x squared plus 1 squared. Safe stop answer, but multiple choice is going to clean it up a little bit. So I'm going to distribute that minus 2x and then collect like terms. Negative 5x squared plus 4x plus 5 all over x squared plus 1 squared. Alright, you can see how we're starting to put things together today. Because you're going to have to know the power rule and the trig rules, and you will use them as you also use a product rule or a quotient rule. So as always in math, things start compounding, and if you don't know the background stuff, then there's no way to add on to it if your foundation isn't there. Number 2, find the instantaneous rate of change. Again, that just means derivative. Again, not everybody writes out all the pieces. I think it's helpful for the quotient rule because otherwise it's just too much. So you try number 2. There's y prime. Can I reduce the cosines here? Yeah, not if you want to stay in the class and pass. No, don't do that. Why can't I, right? Like, why can't I reduce cosines? Yeah, that top one's being added, so you're ineligible to be reduced if you're added to something. So the bottom one's eligible for reduction, but the top one is not. So we just have to leave it as is. I suppose we could factor out an x. Back in the years when we used the textbook more often, the textbook would always give, it wouldn't give answer. It would give answers, but not solutions. And so the textbook would do crazy things like factor out an x. That's not too crazy, but we don't have to worry about that. Like that's plenty good enough. Number 3, find the slope of the tangent line to the curve. Okay, so that's just the derivative at pi over 3. That's what we're looking for. So again, same thing. The top is f, the bottom's g. Find the pieces and then put it all together. Again, if you can jump the step of labeling f and g and finding the primes, if you can jump straight to putting it all together, that's fine. I just feel like mistakes are made when people try that. Jace, how about the derivative of secant? You weren't here for a while. We'll put you to the side. Kira, how about the derivative of secant? Good. Secant x tangent x. And Alan, what's the derivative of x? Yeah, I mean it's supposed to be the easy one, but yeah, that's just 1. So that should make the quotient rule a little bit easier if one of the pieces is 1. Okay, so gf prime comes first. X secant x tangent x minus secant of x all over x squared. And then I've got to plug in pi over 3. Pi over 3, let's see, secant of pi over 3. Cosine pi over 3 is a half. Flip that over, I get 2. Tangent of pi over 3 is root 3. That's the tangent 3 trick. Secant of pi over 3 we just found. That's still 2. All over pi over 3 squared. What a mess of an answer. So let's see. That would be 2 pi root 3 over 3 minus 2 over pi squared over 9. By the way, that was a safe stop, that last step. You've got to plug in on the safe stop. You can't stop short and say, well, let me just plug it in. Like, you have to show the plug in. Then you've reached a safe stop. Multiple choice is going to clean that up. Multiply top and bottom by 9 to get rid of that 9 denominator. So let's see. 9 over 3 is 3. Times 2 is 6. So 6 pi root 3 minus 18 all over pi squared. What a lovely answer that is. And so we're only 3 weeks in, and look how much stuff we did on that one problem. You had to know the quotient rule to put all the things together. You had to know the derivative of secant. You had to know the derivative of x. You had to plug things in. You had to know 2 unit circle values, and then you had to be able to handle some serious fraction algebra. So it's like 7 sort of different math lessons at different points in your math history, and you got to be able to put them all together to get the final answer. And you've seen the stamp before, but maybe that was worthy of it. If your algebra isn't strong, then you can't get through all 7 of those steps to get to the right answer. Or if your calculus isn't strong. But usually, I don't know, it's weird. Like by the time you're seniors, I guess your brain has developed, your study habits have developed. Like you're good on the calculus. And so, I mean, the stamp is a joke, but it's also true. Like most of the mistakes are the algebra mistakes. Like you've matured enough to know, like, I need to learn this, I want to do well, so I'm going to learn what we're going over, I'll learn the calculus, but if all that background stuff isn't there, then things go awry somewhere. Number 4, and then we'll almost be done. Why don't you try number 4? Something kind of funny happens, but funny in a good way. happens pretty quick, actually. So, again, I really like labeling the top and the bottom F and G. It helps me keep things straight rather than jumping straight into the quotient rule. What's F prime? What's the derivative of the top? 0. So that may seem weird, but it's actually good because lots of stuff is going to go away. All right, so you see if you can finish that out. So again, the 0 is helpful because it wipes out one of the terms. So GF prime goes away because F prime is 0. So negative 21x squared over x cubed plus 8 times 2. Not times 2. Squared. Brain isn't working this morning. Oh wait, that's not the final answer. What's wrong with that answer? Why is that not right? I got to plug in 2. So at x equals 2, negative 21 times 4 over, I'm going to ultimate do a super safe stop on this one. Safe stop, right? There is much to be done, but I don't want to do it. So you've seen this. Most of the time I will carry the algebra all the way through because that's what multiple choice will look like. But I do feel like I want to safe stop occasionally just to remind you that that is a perfectly okay answer. If it's a free response question, you do not have to. In fact, you probably should not start to multiply it out and reduce. Not because you can't, but because, maybe 1% of the time you'll make some goofy mistake in there. But maybe more than that, depending on the person. But why risk it? Just leave it alone. Walk away. Be done. And so that's what I'm going to do with that one. If you did reduce it, and you want to see, it reduces to negative 21 over 64. Higher order derivatives. Somebody in one class asked, do we ever do a derivative again? Yes. And we just call it a second derivative, or a third derivative, or a fourth derivative, and so on. First derivative and second derivative have lots of meaning. Third derivative, fourth derivative. Third has a little bit of meaning. Fourth, fifth, after that, physical, real world, actual applications. First and second have a ton of meaning. Third, not so much. The third derivative does have a funny name. Let's put these on here. The first derivative is velocity, change in distance over change in time. How many of y'all had physics last year or this year? Probably most of you. Okay. So if that's distance in time, change in distance over change in time is velocity. If we take a derivative of velocity, so if we have the change in velocity over change in time, what's that called? That's acceleration. And we probably don't talk about this in physics, unless your physics teacher knows it and wants to be funny. And we don't ever really use it in math, but it has a funny name. So I'll mention it here. The change in acceleration. Think about what it feels like when acceleration changes in a car. So you're driving in your car, you feel the acceleration. If you change the acceleration, so what did you say, Gregory? I thought you said something. You made a motion. If you hit the brake suddenly, some of you are doing it, your head, how would you describe that? Whiplash. It's a whiplash if you hit the brake, that's true. If you hit the accelerator, it jerks your head backwards. And so the third derivative is called jerk, which leads to math humor t-shirts. Don't be a third derivative. Niche humor. Wear that shirt. Nobody knows what you're talking about. I need to get that shirt. I did go with a joking math shirt today, but not the jerk shirt. Right? Math camp is greater than regular camp.
Oh.
Yeah, you're like, oh, that would be awful. All right, today's assignment is worksheet number 5. Product rule, quotient rule.